Okay, it looks like the last video, 8.8c, as in Charlie, and we are going to start a section on hyperbolas, and the book only really goes into about 3 pages, so it shouldn't take too terribly much long. This is the first page on hyperbolas, and just to go over a little bit of an explanation of what they're talking about. This is what a hyperbola looks like. And our focus, different than an ellipse. An ellipse, the focus is on the inside, and here it's on the inside here, but just kind of on opposite ends here. So there's our focus here, there's our vertex labeled with an A, and our focus is labeled with a C. And from the focus to any point on the hyperbola back to the other focus, if you subtract the distances, you will get a number. And it doesn't matter where you draw that line. If I were to make my number here and here, those distances would be the same. The difference between them would be, if it was 3 here, it would be 3 if I subtracted here. So that's in the definition of a focus, or a hyperbola. So just some things there. Down here are the standard forms. Notice that the difference between the equations of a hyperbola and the equation for an ellipse is this sign right here, a plus or minus. Notice that on a horizontal hyperbola, which is the same as with an ellipse, the x is first, y is second. On a vertical, the y is first, the x is second. So just like an ellipse, but we've got a minus sign here, and they're both also equal to 1. And notice the horizontal hyperbola looks like this, with the axis going through, or being horizontal, and here the axis is being vertical. So that's how you determine real quick whether or not just from looking at the graph, whether it's horizontal or vertical. And let's just go ahead and get started with one, because I do things just a little bit different than what the book does, and I want to show you that, and hopefully that'll make it easier for you. So let's look at example number 3 here, where we have 9x squared minus 4y squared equals 36. Okay, so the first thing we need to do is make that 36 a 1. Okay, like that there. Okay, in order to do that, again, just like on the ellipse, we divide each term by 36. 9 over 36 is 4. 4 over 36 is 9. Equals 1. Actually, it's 1/9 and 1/4, but we don't have to show the ones there. All right, so there is my ellipse, or my hyperbola formula. Now notice that the x squared has a 4 under it, and the y squared has a 9 under it, and that shows me that we're talking about a horizontal hyperbola. So graphing this thing, okay, the book shows a different way to graph it. I like this way because I like simple. What I'm going to do is I'm going to look at my x, and notice my x has under it the 4. So I'm going to take the square root of 4, and that's how far I'm going to go from the origin. 2 and 2 in both directions. My y squared has under it a 9. So on my y-axis, I'm going to take the square root of that and go from the origin 3 to 3. Now in this particular one, it's the origin because, just like the ellipse, there's nothing added or subtracted to the y, so that means my center point is at my origin. So really, I guess I would have been more correct to say 2 over from the center point in both directions, and 3 over, or 3 up or down, from the center point in both directions. Okay, so once I get that done, I'm going to make a rectangle. Okay, and then I'm going to draw a line that does that. And then, because I know that this is a horizontal hyperbola, this is my vertex, this is my vertex, and I do not cross either one of my black lines. Okay, give me my pen back. So there's one, and there's the other. So I don't cross the black lines, I know my vertices, and I'm done. Okay? The book has you find the slope of these two black lines here for your asymptotes. You don't really even have to do that. You just know my y is up and down 3 from the center, my x is left and right 2 from the center. Draw my lines through the corners of my box, and there's your asymptotes without having to actually find the slope. So that makes life a little bit easier. Okay, so let's look at what happens when we have a shift. When my graph is not on the origin. So let me get a picture here, and we will kind of go from there as far as having a little bit of a change in our formula here. And there's our book, and there are our vertical and horizontal shifts. Let me make this bigger here. We have our two equations, one with the x first, one with the y first, with our minuses, and then notice our h and k. Okay, these are our center points, just like we did with circles a while ago. We said that our h and k were the center points of the circles, and that's what these are. They're the center points of the hyperbolas. So let's go ahead and just write one on here in the correct form. Let me move this, make it a little smaller so I have room to write. So let's just write x minus 1 quantity squared over 4 minus y plus 2 the quantity squared over 9. All right, so what these numbers on the top do is tell me the center for my hyperbola. So here is the equation here, or the graph here. See if I can make it bigger. Okay, a little blurry, but I think it'd be all right. And what we've got is my center is at 1, whatever makes this 0, negative 2, whatever makes that 0. All right, so that being the case, let's put our center point where it's supposed to be, and the book already did that right there at 1, negative 2. Okay, so next I'm going to do is look at this 4, and because I'm looking at, again, a horizontal hyperbola, I'm going to go over 2 from the center point in both directions. 1, 2, 1, 2. And then I'm going to go up or down 3. 1, 2, 3, 1, 2, 3. And then that allows me to draw my box here. And it looks like they found the slope, but they still have the little things here. And I know where my vertices are, and I can draw my hyperbola from that. Okay, so all the differences between what we did now and what we did in an earlier example, we're adding and subtracting numbers, which shifts the center of the hyperbola to a different place. Okay, so one more example, and we will be done with not only this section, but the entire book. So we're going to go with x squared. This is example 4. And the reason we're doing this is because it's got kind of a, well, everything is done the exact same way, but you just have to be careful with the algebra. Nothing new as far as the hyperbolas go. It's just the algebra that you have to be a little bit careful with. All right, so just like we did with some of the other ones, we are going to put our x's and our y's together. And actually, the algebra all has to do with negative signs and being sure of what you're doing there. All right, so again, I'm going to put my constant, my plus 1, over on the other side. And then I'm going to look at that and complete the square. So let's look at the first one and complete the square. Half of 2 is 1, squared is 1. Okay, this one here, we're going to factor a 4 out before we do anything. So let's just do that. All right, so what I want you to do is look here real quick. If I wanted this to go back to what I was a step before, I would distribute this 4 on each of these terms and make sure I get that. Okay, when you're dealing with these doggone negatives, it's a good idea to do that just to make sure you're doing things correctly. Negative 4 times y squared is negative 4y squared. Negative 4 times negative 2y is positive 8y. That's different than I have here. So something's awry here, and that thing is that needs to be a plus sign. So even though it was a negative here, in order to get this to be a negative 8 here, we had to do a negative times a positive. So it's always good when you've got these negative signs here and you're factoring things out to see if you can go back to your previous sentence here and make sure that you can get back there doing the algebra here. We couldn't by putting that negative, and we would assume that this is a negative, this would be a negative. But what happened is we pulled out a 4, and that 4 became negative here. So instead of a minus this, it's a negative 4 times each one of these. So make sure you watch that and be careful when you're doing that. All right, so now let's go ahead and do the completing the square. So we've got our x squared minus 2y plus 1, didn't do anything there, minus 4, and let's do our y squared plus 2y plus 1. And what we did here is we added 1 here, okay? So we have to add 1 to the other side. Remember to do that. So we had our negative 1, and now we add 1 from this one over here. All right, so what do we add from this here? We add a negative 4 because we didn't just add 1, we added negative 4 times 1, which is negative 4. So we have to do the negative 4 over there as well. All right, so let's go ahead and move all this up and go ahead and rewrite this as x minus 1, the quantity squared, minus 4, y plus 1, the quantity squared, equals negative 4. Okay, give you just a second to look at that. And now we have to divide everything by negative 4 in order to get this to be a 1. Okay. So now we have x minus 1, the quantity squared, over negative 4. Over here, we have a negative and a negative. Negative 4 over negative 4 is a positive 1. Okay, over 1. Okay, we have to have a fraction, so even though there's not a number under there, we put the assumed 1 under there so we know what our value is there underneath the y. Okay, so we don't need to show that one, so let's just kind of get rid of that. And so now what do I have? I've got this negative here and this positive here. Well, because that's the positive, and I like that, and this is a positive, and I don't like that because the formula for a hyperbola puts a negative there, I'm going to do some rearranging here. And it's not really much rearranging. I'm just taking this and putting it in the front. And then this negative here makes the whole thing negative. All right, so when I did that, I did a couple things. I got the y in the front, positive, the x minus 1 here, and with the minus sign here equals to 1, and everything looks good there. So because that is the case, I now have a vertical hyperbola, because it's in this form where the y is happening first, and then it makes it real easy to graph this here because my center is at, what makes that 0 and what makes that 0. Okay, so that's my center, and pretty much that's all I need in order to graph this. All right, let me throw my graph on here again real quick. And my center then is at 1, -1. And my y value is square root of 1, which is 1. So I'm going to have a point here and a point here. And then the square root of that is 2, and that's going to put a 2 here and a 1, 2 here. And then I can draw my handy dandy little box here with my lines through there, like that. And then I can very easily draw my hyperbola. Okay, and that is it for 8.8C.